day everyone, welcome to lesson 1.1. The lesson is entitled Group, an introductory lesson to abstract algebra. So before we proceed to the formal discussion, let's have first our learning objectives so that we will be provided with a clear purpose on which to focus upon learning this lesson. So at the end of the lesson, students are expected to define a group, illustrate the properties of a group, and prove that a set with a binary operation star is a group. I'll expect this from you, students. So one of the most important concepts of abstract algebra is the concept of a group. This is really the fundamental concept of abstract algebra that we need to be familiar with. So let us recall the definition of a group. So a group consists of a non-empty set G together with a binary operation star such that the following properties hold: the closure, associativity, the identity, and the inverses. Let's go back to the closure. So closure says that if we take any two elements in the set G and apply the binary operation star, then A star B should also be in the set G. Associativity, that's the one that we remove the parentheses around, and since we are not talking about addition or multiplication, we're just talking about our general binary operation star, then we can say that A star, the quantity B star C, is the same thing as the quantity A star B star C. Then we have the identity. There's some element in the set, and I'm gonna call that element E. So this one, that's typically what mostly is using when talking about the identity in general. So there's some element E or identity element such that for any A that's in G, then A star E is equal to A. This is also the same thing as E star A. So that's what the identity does. It gives you back the same thing. Lastly, we have the inverses. For any element A that's in G, there exists an element, and I'm gonna call it A inverse, or the inverse of A, that's also in the set G, such that A star A inverse is equal to E, and it is also the same thing as A inverse star A. So this is the definition and the properties of a group. Let us try this problem. In order for us to illustrate the properties of a group, we will show that the given set and the defined binary operation is a group. Let R, or the set of real numbers, together with a binary operation star defined by A star B is equal to A plus B plus the product AB is a group. So in proving, we need to write proof first. So the first thing that we have to show is the closure. So since addition and multiplication of R gives R, then R is closed under addition and multiplication. Clearly, by closure property, the binary operation star is well defined. Because if we do apply A star B, we get exactly what we get, A plus B plus AB. And I think it's pretty clear to see that this would be uniquely defined, right? Because we're dealing with addition and multiplication of real numbers. So if you add two real numbers and their products as well, you get a unique number. So let's proceed to the associativity. Let A be elements in R. Then for all A, B, and C elements in R, so all we have to show now is that A star, the quantity B star C, is the same thing as the quantity A star B star C, this one. Let us verify this first. If we are going to apply the binary operation here, so let's do first the one that in the parentheses. So we get A star, the quantity B plus C plus BC, according to the definition of the binary operation. And so by applying again the definition A star, the quantity B plus C plus BC, we get A plus the quantity B plus C plus BC plus the product of A and B plus C plus BC. So now we get A plus B plus C plus BC plus distribute AB plus AC plus ABC. So by applying the definition, we get the quantity A plus B plus AB star C. So this is not addition, this is star C. Now, applying again the definition, we get quantity A plus B plus AB plus C, this one, plus the product of the quantity A plus B plus AB and C. Now manipulate, we get A plus B plus AB plus C plus distribute AC plus BC plus ABC. If we will look closely, all the terms here are also in here, right? Hence, A star, the quantity B star C, is equal to the quantity A star B star C. Therefore, the binary operation star is associative. Let's proceed to the identity. So by definition, A star E is equal to A equal E star A for all A element in G. Thus, A star E is equal to, apply the binary operation, we get A plus E plus the product AE. Then, we all know that this one is equal to A. So since the result is A plus E plus AE, then A plus E plus AE is equal to A. Now manipulate to get the E. So we get E is equal to 0. Note that 0 is an element in R. Moreover, A star 0 is equal to A plus 0 plus A times 0 is equal to A. And 0 star A is equal to 0 plus A plus 0 times A is equal to A for all A element in R. Therefore, 0 is the identity element in R. So the last properties that we need to show is the inverse. So by definition of an inverse, A star A inverse is equal to E, and it is also the same thing as A inverse star A. Thus, A star A inverse, apply the binary operation, we get A plus A inverse plus A times A inverse. Then, we all know that a binary operation here will be equal to E according to the definition of an inverse. So, A plus A inverse plus A times A inverse is equal to 0, which is our identity. Now, manipulate the equation. We get A inverse is equal to negative A plus 1 all over A for all A element in R. Since for all A element in R, then the quotient of negative A all over 1 plus A must be element in R as well. Thus, A star negative A plus 1 all over A, if we are going to apply the binary operation, we get 0, this one. And negative A all over 1 plus A star A, by applying the binary operation, we also get 0. Therefore, negative A all over 1 plus A is the inverse element of A element in R. Consequently, the set of real numbers together with the binary operation star is a group. So thank you for watching. I hope that the video makes sense. So if you have any questions, you can feel free to email me at the address I posted here.